Now we shall discuss the technique to draw ray diagrams when an object is placed anywhere on the axis. So for this, assume this is a concave mirror and this is what pole, this is center of curvature, the line joining these two, the line passing these two is called principal axis. The topic is when an object is placed anywhere on the axis. This is the axis, principal axis. So now I am here, I am placing an object on the principal axis. So what is the object here? I have taken candle as an object. So here, to draw ray diagrams, two rays are required. At least two rays are required from the same point on the object. So here I am taking this point. So I am taking this point. From this point it should take at least two rays. So this is ray 1 in one direction and I am taking another ray from the same point but in different directions. So thus I have drawn two rays from the tip of the flame in two different directions. So these rays are called what? Incident rays. So first step is, after drawing incident rays you have to draw normal ray. So how to draw normal? From this point to the center of curvature we have to draw normal like this, from point of incidence to center of curvature. This is normal. So after drawing normal we have to measure the angle of incidence. So what we have to do, we have to measure angle of incidence. So this is angle of incidence. With this much angle you have to construct the reflected ray. If this is 30 degrees, you have to construct a reflected ray with an angle equal to 30 degrees. So I am drawing reflected ray here by making an angle equal to angle of incidence. This is reflected ray. Okay. So what is the fourth point here? We have to construct reflected ray such that angle of incidence equals to angle of reflection. Angle of incidence equal to angle of refraction. So in this way we have to take, so how many steps are required? 4 steps are required. So here I am applying the same thing for the second ray. So incident ray is drawn. Now we have to draw normal. This is normal. After that we have to measure angle of incidence. Then I have to draw reflected ray by making equal angle. So this is second reflected. So these two reflected rays meet at this point. This point is called point of intersection. This point is called point of intersection. So that means to get this point of intersection we have done all the process. So for this we have drawn incident ray, normal, measuring of angle of incidence, then we have drawn constructed reflected ray such that angle of incidence equal to angle of reflection. So we have followed 4 steps to find this angle, find this point of intersection. So what is the importance of this point of intersection? So this point of intersection will give you the image of this particular point. So you have taken 2 rays from this tip of the flame, you will get image at here. That means if you place a screen here, you will get clear image of this point at this point of intersection. So in this way we construct these ray diagrams. Now why images become blurred? Why images become blurred? So when do we get blurred images? So here, here in this activity, if you place the screen at point of incidence, that means at A, you will get a clear sharp image. if you place the screen before A or beyond A, that means before A or beyond A, you will get blurred image. So here, if you consider that if you place the screen here before A, so this reflected ray will give one image here, this reflected ray will give one image here. These two images merged with each other unsymmetrically and give you a blurred image. The same thing happens if you place the screen beyond point A. So that means either before the point of incidence or after the point of intersection, sorry, before the point of intersection or after the point of intersection, if you place the screen at any one of these two places, you will get blurred images. Okay, that's the reason we have to place the screen at the point of intersection of these two reflected rays. Okay, so if you place a screen before the point of intersection or beyond the point of intersection, you will get blurred images. So here, is there any simpler method? Is there any simpler method to draw ray diagrams easily? Here, you know that to find point of intersection, we have to follow all these four steps. So these four steps are not at all easy. They are somewhat difficult. So to avoid this difficulty, we follow some simpler method. We use some simpler method to find the point of intersection. So to find this point of intersection, we take some appropriate rays. We take some appropriate rays to find the point of intersection where we get the image. So here these rays are the suitable, also called suitable rays. They are parallel ray, ray passing through pole, ray passing through focus, ray passing through center of curvature. Suitable rays for concave mirror. The first one is, this is what, parallel ray, and the second one is the ray passing through focus, and the third ray is the ray passing through pole, and the fourth ray is the ray passing through center of curvature. So these are the four suitable rays for drawing ray diagrams for concave mirror. Let us see the first one is. What is the first one here? Parallel ray. So here this is concave mirror and this is non-reflecting surface. You know that this is pole, and consider this is center of curvature, and this is what? Principal axis. So what should we have to take? We have to take a parallel ray. This is the parallel ray to the principal axis. So in the second step, after drawing parallel ray, you have to draw the normal. You know that drawing normal is always drawing line from center of curvature to the point of incidence. So I am drawing. Okay. So here, so you know that the midpoint of pole and center of curvature is nothing but focus. Okay. So now I have drawn, what is it? I have drawn parallel ray, and this is what? This is normal. Now we have to draw the reflected ray by making this much angle. So I am drawing. This is what? Reflected ray. So here, so the parallel ray is reflected through focus. So next time when you draw a parallel ray, you need not to draw the normal. Simply you have to draw its reflected ray through the focus. So if you take any parallel ray, that parallel ray will be reflected through the focus. So that's about. So every parallel ray will be reflected through focus. And let us see second one. What is the second one here? Ray. The second one is ray passing through. The ray passing through focus. So this is what is this? This is concave mirror, and this is non-reflecting surface, and this is the midpoint of the mirror, which is called pole, and this is what center of curvature. This is the line passing through pole in center of curvature, which is nothing but principal axis, and this is the point where we have to draw focus. Midpoint of pole and center of curvature is what? Focus. So which ray we are taking here? The ray passing through focus. So I am taking a ray from here. This is the ray passing through focus. Okay, incident here. So here what we need to do is, after drawing a incident ray, you have to draw the normal. So now what is normal here? You have to draw a line from center of curvature to point of incident. Simply draw a line, dot a line from point of incident to center of curvature, and this is what? Normal. Now we have to now we have to draw the reflected ray. So by making the same angle, so this is the reflected ray. This is what? Reflected ray. So here, this reflected ray, if you observe the reflected ray, it is parallel to the principal axis. The reflected ray is parallel to principal axis. Means the line passing through focus, the line which is passing through focus, will always be reflected parallel to the principal axis. That means we are taking a ray passing through pole. Ray passing through what? Pole. So here this is pole. So I am drawing a pole, right? So this is what? Incident ray. This is the point of incident. See here, the line, the principal axis, here it is principal. The principal axis here acts as a normal to this ray. Here for this principal axis, for this ray passing through pole, this principal axis acts as a normal. So here we have to simply draw a reflected ray by making this much angle, So by making this angle, draw the reflected. So if you take this ray, you need not the ray passing through center of curvature. So here the principal axis is also the ray passing through the center of curvature. So this is the first one, and I am taking another ray which is passing through, center of curvature. See here, we know that any ray, passing through center of curvature to any point on mirror. Is nothing but normal to that particular point. So that means, this line is also normal, and this line is also normal. Any ray which incidents normally, will not get deviated. Okay, that means it will not get deviated. That means the ray will be reflected. The ray will be reflected in the same. The ray will be reflected in the same path. So this ray is also reflected in the same path. So if you take another ray like this, So this is the incident ray and it will be reflected in the same path. So thus this is the fourth ray. So the first one is, what is the first one here? The first one is parallel ray and the second one is ray passing through focus and the third one is ray passing through pole and the fourth one is ray passing through the center of curvature. So here by using these four rays you can draw the ray diagram simpler and easily. So for drawing any ray diagram you need two rays. You can take any two rays from these four rays. So these four suitable rays makes the ray diagram for concave mirrors are easier. So now let us see the ray diagrams for concave mirrors. So the first one is when the object is at beyond C. First you have to get the image of the top of this object, you have to draw two rays from this particular point. And those two rays should be taken from the suitable rays which I told just now. So what are those four rays? Parallel ray, the ray passing through focus, the ray passing through pole, the ray passing through center of curvature. So you have to take any two rays from this. So every time you have to take the first one should be parallel ray. So what is it? So this is the first ray, so which is parallel to the principal axis. And now I have to draw another ray from here. So here for this I am taking a ray which is passing through focus. What is the second one? The ray passing through focus. So this is the ray. This is the ray passing through focus. This is second ray. So here the first point, what is the first point? You have to draw two rays. How many draws you have to draw? Two rays. Then you have to draw the reflected rays. You have to draw the reflected rays. So you know that every parallel ray will get reflected through focus. So that means the reflected ray should pass through the focus. So this is the reflected ray. Every ray passing through the focus will be reflected parallel to the principal axis. So what I am doing, so I am drawing this is the second reflected. So here these are the two reflected rays. So the point where these two reflected rays meet, there the image will be formed. There the image of this top, the tip of the object image will be formed here. So third step, you have to draw a line. You have to draw a line from from this point to principal axis. So now we have to draw a line from these two principal axes. So this is what? This is image of this object. So here this is object and its image is found here. So this particular point is the image of this particular point, and this is the image of the base of the earth. Its image formed here, its image formed here. If it is head, the image of the head is formed here. If it is base, the image of the base is formed here. Your head is on the top, your head is on the bottom. That means the image get inverted. Here you got what? You get invert image. Okay, so in this way we have to draw the ray diagrams when object is placed at beyond C. So when object is placed at beyond C, so image. So image formed between C and F. Between C and F. Image is formed between C and F. Center of curvature focus. And the second point is, so here, how do you get the image? So to get this image, you have to place the screen. So consider this pen is a screen. If you place the screen, you will get blurred image. When you go on moving like this, at this point you will get the brightest, very clear image. So that means the image is caught on the screen. Here the image is caught on the screen. So the image is real image. And the third one is, you know that I said this is bottom, base, and this is top, tip of the object. Here its image, the image of this tip is formed here, the image of base is formed here. That means both gets inverted. So this image is nothing but inverted. If you are unable to decide whether it is inverted or inverted image or not, then see here the image is just below the principal axis. So this is what principal axis, the image is below the principal axis, so it will be inverted image. And see here the object is farther from the mirror, but here the image is nearer to the mirror. So when the object is near, the image will be diminished. That means the size of the image will be less than, smaller. The size of the image is smaller than the size of the object. So here you get diminished image. What kind of image you will get? Diminished image. Place the object at C. So here you have to take two rays. The first one is parallel ray. This is ray 1, and the second one should pass through focus. So this is second ray. So then we have to draw the reflected rays. Every parallel ray will get reflected through focus. So this is what reflected ray. And every ray passing through focus will be reflected parallel to the principal axis. So parallel to the principal. This is the second difference. These two reflected rays meet at this point. So now we have to draw a line from this point of intersection to the principal axis. We have to draw a line from this point of intersection to the principal axis, which will give the image, of this object. So here we have taken object at C, and image is also formed at C. Here when object is, say, image formed at C. So this is the first point. Second point, here this image is also caught on the screen. It forms on the screen, so it is what? Real image. And it is also below the principal axis. In the principal axis, the image is formed below the principal axis. So this is what? Inverted image. And the object distance is the same as the image distance. So the image will be of same size as the object. We have to draw two rays. The first ray is parallel ray. This is first ray. And the second ray passing through focus. This is second ray. So now we have to draw the reflected rays. You know, every parallel ray will be reflected passing through the focus. This is what? Reflected. And here the ray passing through focus. So it will be reflected parallel to the principal. This is principal axis, and this will be reflected parallel to the principal axis. So I am drawing. So here this is first parallel ray and first reflected ray. This is the second reflected. These two reflected rays meet here. So here from this point of incident you have to draw the line to the principal axis. So this is the image. So this is the object and this is the image. So here, so where is the image formed? So the image formed at beyond C. Image formed at beyond C. And the second one is, so here if you see the image formed below the principal axis, so it is inverted image. And the third one is this image should also be caught on the screen. That means if you place the screen you will get the image. So here it is also real image, and if you see this is the object distance and this is the image distance. So image distance is greater than the object distance, so this image will be bigger in size. That means this is what kind of image this is, a large image. So these are the characteristics of this particular image. So next one is when the object placed at focus. So here the object placed at focus. So now we have to draw first ray, that is parallel ray. That's first ray. And the second ray, here object is placed at focus. We cannot draw the ray passing through focus. That's the reason I am taking the third suitable ray, which is the ray passing through the pole. So now I have to draw a ray. So this is what? Second ray. So both the rays were drawn. Now I have to draw the reflected ray. So you know that every parallel ray reflected through focus. So now I have to draw a ray like this. This is the reflected ray for the parallel ray. Now the second ray, the ray passing through pole, will be reflected by making this much angle, by making angle equal to this angle. So now so here, so thus here if you see these two rays are moving away. So here these two rays meet at infinite distance. So the image will be formed it. So image forms at infinite distance. The image formed at infinite distance, and here this image should also be caught on the screen. So this is real image, and this image is formed below the principal axis. So this is inverted image, and this image will be formed at a infinite distance. So this will be highly enlarged image. The image will be highly enlarged image. In some textbooks, so nothing was given here. So they simply kept blank without writing anything. But in central syllabus books, it is mentioned that so it is the image formed when object placed at focus will be highly enlarged. So the object is placed between pole and focus. So the first ray is parallel ray. You know that this parallel ray will get reflected through focus. So this is a reflected ray for parallel ray. So the second ray, you can take the ray passing through pole You can also take the ray passing through center of curvature. So but here if you see this image, you will come to know that the center of curvature is behind the object. So now here you have to assume that the ray is coming from the center of curvature by drawing like this. See here what I am doing is I am just drawing a line from center of curvature. This is center of curvature and this is the object. So this is the ray. Just imagine that the ray coming from the center of curvature, the ray passing through the center of curvature, the ray coming from the object and it is passing through the center. You know that any ray that passing through the center of curvature is nothing but normal. If any ray incidents normally, it will be reflected back in the same path, right? So if you observe these two rays, this is the first reflected ray and this is the second reflected ray. These two rays are diverging. These two rays are diverging. That means they do not meet at any point. So that's the reason what you need to do is you have to extend these two rays. What you need to do, you have to extend these two rays. And this one also, extend this one also. So here when you extend these two rays, those two rays meet at this point. So that means here you will get the image of this object. So you know that you have to draw a line from this point of incidence to principal axis. So you will get image here. So here the image is formed behind the mirror. So here the image is formed behind the mirror. And second point here, if you observe this, the image is not forming on the screen, it is formed behind the mirror. In the sense it is formed inside the mirror. That means the image formed in the mirror, so it is virtual image. It is what? Virtual image. And if you see, the image is above the principal axis, so it is erect image. And if you check the size of the object and the size of the image, you will find that the size of the image is much bigger than the size of the object, so it is an enlarged image. These are the characteristics of image that are formed when object is placed between pole and focus. Thanks for watching my video. Please like and subscribe SS Academy if you like this video.